Hello, everybody. So today we're going to be filling out the 12.1 notes. But before we do that, chapter 12 is all about bivariate data, which we went over a bit in chapter 3, I believe. So really quickly, I just kind of want to go over the stuff that we learned back in chapter 3. So when we are calculating a line of best fit, it is written as y hat equals a plus bx, where b is the slope and a is the y-intercept. So how we interpret this, b is the slope, and how we phrase what b is we say for every 1 unit increase in whatever that explanatory variable is, x, the predicted or response variable, y hat, will increase or decrease by whatever the slope is, depending on whether it's positive or negative. Okay, the y-intercept is a, and we explain this by saying when the explanatory variable, x, is 0, then the predicted value, or the response variable, is whatever that y-intercept is. Okay, the residual is the actual value. Okay, so it's y minus y hat, which is actual minus predicted, okay? It's the observed minus the predicted. So this is the actual response variable, the x value. No, y value. Sorry, guys, I'm on top of things today. It's early. So the actual response variable is whatever the residual value is, more or less than the predicted value. So depending on whether this comes out to be positive or negative, you would say the actual, whatever y is representing, is this many more or less than the predicted. Okay, standard deviation of the residuals. On a computer output, capital S, on average, the predicted values will be about S value of the response variable away from the actual values. So capital S here is the standard deviation of our residuals. On average, how far away are we predicting from the actual values? Okay, coefficient of determination, R squared. This explains the percent of the variation in the response variable that's accounted for by the explanatory variable. So how much of the variation in y is accounted for by x? Okay, correlation coefficient. Talking about correlation, we use weak, moderate, or strong. So some general guidelines here. If r equals 0, there's no correlation. If it's less, it's between 1 and -1, you still would pretty much just say no correlation. Okay, anything between 1 and 4 would be a weak correlation. Anything between 5 and 7 is moderate. Ooh, interesting. Maybe these are like the in-between. Okay, and anything between 8 and 9 is strong. So I guess if it's between 7 and 8, you say moderately strong. Between 4 and 5, you say moderately weak. And between 0 and 1, you say very weak. So that is kind of the phrasing we use. All right, so in the next video, I'm going to jump into the 12.1 notes. I just wanted to give us a quick little overview of bivariate data.